So welcome everyone to Builders Declare Australia's second webinar, Introduction to Passive House. Now, we received an overwhelmingly positive response from our first presentation, Roadmap to Carbon Zero Homes, and I expect today's presentation to be no different. Once again, my name's Simon Clark, one of the 10 founders of Builders Declare and Director of Sustainable Homes Melbourne, and I will be your host this evening. I'd like to again begin by acknowledging the traditional owners of the land on which we meet today. I would also like to pay my respects to elders past, present and emerging. Now, Passive House gets a mixed response from a lot of people. Some love it, a lot of people love it, and a lot of people challenge it. Is it required in Australia's climate? Is it worth it? Yada, yada. And this is a debate for another time. As per our presentation last week, Roadmap to Carbon Zero Homes, there's many ways to achieve high-performing homes, and Passive House is one of those ways. One thing I do know with Passive House is that it is an elite way of building. I mean by that, the average Joe builder cannot execute to the Passive House standard without a great degree of knowledge. And in my humble opinion, it is that if a builder can build to a Passive House standard, they can build pretty well any high-performing home. And that's what we're about here at Builders Declare. Builders Declare's mission is to drive the Australian building industry to a more sustainable future by sharing knowledge and experience on the construction of high-performing homes, and share knowledge and experience on lowering the embodied energy of construction practices. We plan to bring a webinar to you guys every month. We've got some presentations lined up, some really interesting ones coming your way. A few that are in the pipeline is we're looking at sustainable building materials, sort of analysis on that, from hoping to get Paul Haar from the Mullum Creek estate here in Melbourne. Danielle King from Green Moves, looking at carbon auditing our businesses. Another one in the pipeline is Daniel Baggs from Eco Specifier and Global Green Tag International to talk about life cycle analysis. So moving forward, we'll be charging a small fee, likely $5, just to cover costs of this software that we're using, and we do hope you all understand. Our Builders Declare's network is growing each week. Last presentation we had 133 signatories, and today we have 161. Once again, we're dominated by Victorians, so all you builders, tradespeople and suppliers from Victoria and all around Australia, get behind Builders Declare, sign the declaration, and anyone can be part of these education. So look, get all your trades, all your employees, and get behind it. If you want to find out more of Builders Declare, you can contact us via email. You can visit au.buildersdeclare.com. You can also join the conversation at our Facebook page. We have a Facebook group and Instagram, which is growing quickly. So our event today, an introduction to Passive House, will be presented by Jesse Glascott of G-LUX Homes and Hamish White of Sanctum Homes. Now, Jesse is a qualified carpenter with over 20 years in the domestic and commercial industry. His journey started with his carpentry apprenticeship and led into his own business at the age of 21. And he quickly became a registered builder at age 24. Now, Jesse discovered Passive House in 2017 and undertook his qualification to become a certified Passive House Tradesman. And since then, he's redirected his entire organisation, G-LUX Builders, to focus on energy efficient, high-performing builds and Passive House. Now, Hamish was educated at La Trobe Uni with a business and marketing degree. After completing this, he quickly realised being stuck in an office was not for him, like so many of us. He started his carpentry and building journey at the age of 23 with a keen interest in the outdoors, and his wife being an ecologist. Hamish's passion for building and the environment led him down the path of sustainable building, and now high-performing homes and passive house. Building high-performance homes is now Sanctum Homes minimum standard. As a founding member of Builders Declare, Hamish is hoping to encourage other builders and tradespeople to build better homes and be more mindful of the environment. So, Introduction to Passive House offers a reliable pathway to high-performance construction. In this webinar, the boys will show you what it takes to construct a passive house from a hands-on builder's perspective. Hosted by passionate advocates of Passive House, Jesse from G-LUX Builders and Hamish from Sanctum. They'll discuss the principles underlying Passive House and share their experience of it in practice and show you in detail on a scale, with a scale model of what it all means. So you've heard enough from me. I'll hand over to the guys now. But before I do, we'll have, again, put your questions in the Q&A box down below, and we'll save 10 or so minutes at the end of the presentation for some questions for the guys. I'll hand you over to Hamish and Jesse.
Alrighty. Thank you, Simon. Thanks for the intro, mate. And thank you to everyone attending tonight. Hamish and I are pretty excited to be hosting Builders Declare's second webinar and the first one on Passive House. And I guess from our point of view, we're going to be talking about Passive House from a builder's perspective. So let's maybe just start with discussing the history of Passive House. So it originated over in Germany back in '91 by Dr. Wolfgang Feist. His home is up there, up on the right-hand side. That's a family home that he created and built. So Passive House is one of the leading energy efficient standards from Europe. It's become a global standard now all around the world. The benefits of a passive house, not only it's a healthy and comfortable home, but it's highly efficient. It can use considerably less energy, up to net 90% than a conventional build. So I guess we're going to talk today about the 5 principles of Passive House. Thanks to the Australian Passive House Association, we've captured this image here. It's pretty well known. We've got insulation, passive house windows, ventilation, air tightness, and thermal bridge design. Now these are all critical aspects of the design and also the build process. So I'll throw it over to Hamish and he'll start with insulation.
Thanks, Jesse. G'day everybody, and thanks again for joining us today. It's really great to see so many people wanting to know a little bit more about Passive House. As Jesse said, first up I'm going to talk about thermal insulation. Now in a typical passive house build, you would generally see thicker wall build-up. In the model that we're going to show you a little bit later on, we've got a 140 stud, which will allow an R4 insulation batt to go in there. What's really important to note is that the climate data for the area is the real driver for R values. In the passive house project that we've got coming up in Kyneton, it's called up for R6 on the underslab, R8 in the walls, and R10 in the roof. Whereas our passive house in Viewbank is R2 under slab, R4 in the walls, and R7 in the roof. Now, Kyneton's obviously a colder climate, so there's a greater need for a higher insulation, just because there's temperature differentials between inside and outside, or greater swings in temperature differentials. One of the most important things to consider in the insulation in a passive house is that it needs to be continuous. Proper planning is really crucial. You need to insulate the external corners and the wall junctions before your external wrap goes on. If you don't do these things, you can create a thermal bridge, which is something that Jesse will talk about next. Some of the advantages of a high-performing bulk insulation: it stops heat gain in summer and heat loss in winter, which helps control the internal environment. It helps protect the structure by eliminating cold spots, which can lead to moisture buildup and mould. And I guess as a byproduct of a thicker wall and a thicker insulation, you have better acoustic performance. Next slide, Jess. Just going to talk now a little bit about a couple of types of insulation. Fiberglass or wool, which is your bulk insulation. EPS, which is expanded polystyrene. This is something that we typically use in a SIP panel. SIP's construction is something that we really like at Sanctum Homes. It won't degrade. It's reasonably impervious to moisture. And it can also be used as an external cladding, and you can just put a render finish on it. The next point is XPS, so extruded polystyrene. It's a thinner board and it gets higher R values. This is something that we would typically use underneath a slab. It has a high compressive strength, and it can usually be installed under internal and edge beams while still maintaining the required bearing capacity. So it allows us to have that continuous insulation the whole way around the house. And again, it's reasonably impervious to moisture. Another product, a PIR board, for example, Kingspan. If you look at the picture that's here on the slide, Jesse's used that in between some layers of yellow tongue. It's a rigid board, high compressive strength. It's closed cell, so it's impervious to moisture. And it's also airtight. So it can also help with our airtightness barrier, which is something we'll talk about later on. It's just really important that we are hitting our R values when we're constructing a passive house. It's really, really important that we check over all the insulation before we cover it up, either with our external wrap or our internal linings. Don't stuff insulation into a cavity. Fibre and wool products can slump, creating cold spots. As mentioned previously, just make sure that you insulate all your wall junctions and external corners prior to your external wrap going on. We actually keep all our XPS and EPS offcuts, and we'll use these in these junctions and cracks and nooks and crannies, and then just put foam, low expansion foam around them to eliminate any air leakages. And it also saves from going in landfill as well. Over to you, Jess.
That's it, is it?
That's it. Over to you. Yep.
All right, mate. Well, I draw the short straw out of this and got thermal bridge. I know it's not the most exciting element or principle out of the 5, but I think it's a very important one, and one that you have to do a lot of attention to detail, not only in the design process but also out in the construction. As you've probably all seen out there before, condensation built up on a window, just like this photo we've got here. Well, that's from the different temperature differentials between inside to outside. So what I want to sort of discuss is pretty much the basics of a thermal bridge. So it's pretty much a highway for unwanted energy loss or gains from outside the building to inside the building, or vice versa. So as Hamish just pointed out, it's very important to have a continuous insulation, and that will help, if not eliminate, a thermal bridge if you've got that continuous insulation. Not only has to be continuous, it has to be sufficient as well. So it's something that you definitely don't want to get slip up on. You know, once a house is cladded or plaster and you've got gaps of your insulation, you're going to get a thermal bridge through those gaps. Now, if there are going to be penetrations on builds, if there are penetrations that you haven't accounted for that happen to come up on you during construction, look, don't stress, just speak to the designer, say, I've got to put a waste pipe in here. Unfortunately, we can't do it with just one waste in this area. And, you know, you'll come up with a solution. The designer will do some PHP calculations, and I'm sure you'll overcome it. In some circumstances, we've had to add a little bit of high performance insulation in some spots and managed to get it over the line. The main issue I see with thermal bridges is condensation build-up. Condensation creates mould, and obviously mould is a huge health risk. And to stop mould from happening, we have to stop condensation from happening. So the general rule with how condensation is created in a house is if the indoor surface temperature is less than 13 degrees, but the air temperature inside the house is 21 degrees with a humidity at 50%, that's when condensation will occur. Now, obviously, mould brings higher health risks, you know, dry cough, flu-like symptoms, fatigue, shortness of breath. That's just to name a few. So I want to jump into some examples now of some thermal bridges and how we can eliminate them. Now, this construction detail, thanks to David Halford from Sustainable Building Design, has a typical 90mm wall construction here. We've got the purple stuff purple pink is the insulation in the wall, and we have a steel column here. We've got a ventilation cavity here with our cladding external. So without any insulation around the steel column, you can see the internal surface temperature is at 10.4 degrees. Now, if we go down to the image number 2 underneath here, you'll see what we've done is we've added some PIR to the face of the column here. Now that is in the batten cavity depth of the surface cavity here, of the ventilation cavity. By doing that, we minimise the thermal bridge, and you see the surface temperature inside is increased to 14.75 degrees. So we're above the 13 degree dew point inside now, so you're not going to get the condensation. This is a construction detail, which is actually the construction method that Hamish just showed before with the PIR in between our yellow tongue. So we wanted to build this house frame as conventional as possible. So typical subfloor, typical wall frames. We didn't want to have a continuous insulation under our internal floors when we were building the frame. So we spoke to the designer, come up with a solution, what we wanted to do, build the internal walls down onto the chipboard, and come up with a solution to minimise the thermal bridge. So we had offcuts of the PIR board from other parts of the project, as well as the floor here, and we actually cut them up, put them in between the studs on top of the bottom plate, and didn't eliminate a thermal bridge completely because obviously the studs, we've got studs every 450, but was enough to work for the calculations in the PHPP, and wasn't a problem in the end. This detail we've got here is a couple of window installation details. This window frame we've got here, and we've got generally we've got a 10 to 15 mil perimeter gap around the window before it hits the stud here. So with this photo, we've got no taping on the outside, so you've got outside air filling up this void. Now you're instantly going to have condensation here. You've got surface temperature inside of 8.62 degrees. So it's a pretty easy fix, this one. Fill up around the window with expansion foam. Make sure you tape externally as you would tape internal for air tightness. What that does is that gets rid of the external air from the pocket. The expansion foam doesn't have much of an R value, it's more just getting rid of that air. And then you can see the surface temperature 14.26 above the 13, so no condensation issues on this one. Over to you, Hame.
Thanks, Jess. Next I'll be talking about high performance passive house windows. Some of the key features of passive house windows and doors are that the windows themselves or the frames themselves are thermally broken, or they're made of a non-conductive material like UPVC. So what this means is there's no thermal bridging, and we're probably repeating ourselves a little bit, but it's a point we want to drive home that an aluminium frame, which can result, that's not thermally broken, can result in heat and loss gain, which causes condensation, like one of the previous slides. So it's really important that the windows are either non-conductive material or thermally broken. They also want to be airtight, so that's one of the other pillars of passive house. A typical airtight window might be a tilt and turn or a lift and slide. And they're usually double or triple glazed, and depending on the climate, they might have a low E film or other high performance glass. As Jesse was just pointing out before, the installation of passive house windows is really crucial to the success of a passive house project. Not only must the window and door be airtight, but the frame in which it's installed also needs to be airtight. So we'll do this internally and externally, as Jesse said before. I might just talk about some of the practical ways in which we do that. And we'll also demonstrate this in a video. We would typically tape a strip of Intello internal wrap to the window prior to installation, and then we'll tape that strip back to the frame. Now, as I said, we'll demonstrate this in a video a little bit later on. We'll also tape the window externally to the wall membrane, and we'll also use low expansion foam, as Jesse said, between the frame and the timber, between the window frame and the timber frame, and this helps with heat loss gain and also air leakages as well. We're not actually relying on that, as Jesse said, for a high R value, but it's better than having just air rolling around in that space. What is a U value? Now, it actually took me a long time to get my head around a U value. A U value, it's quite important when selecting passive house windows. So we want to go for the lowest U value possible. So a U value is the measure of the flow of heat through an insulating or building material. So whether that's the glass or the frame of the window. And we'll usually talk about that as its installed value. So rather than just talk about the glass or the frame, we want to know what that window is, what's the total U value of that unit installed. And again, we want that to be as low as possible. How is a U value different to an R value, which we're probably more familiar with? So an R value is a measure of resistance to the flow of heat through a given thickness of material, such as insulation, with higher numbers indicating better insulating properties. It's probably important to note here that all the information that goes into certifying a passive house and that I guess goes into the success of a passive house and drives how we build it is all analysed in the passive house planning package, which uses clearly defined building physics algorithms. And that's actually beyond my personal knowledge, but you can rest assured that software definitely does its job. So I'll hand over to Jess now. Or am I on airtightness? Oh, no, that's me.
Yeah, mate.
Yep. So as we talked about before with the windows, they want to be airtight. So not only windows need to be airtight, but the building needs to be airtight. We're looking at, in a passive house, a certified passive house, 0.6 air changes per hour at 56 pascals of pressure. Now, according to the CSIRO, a typical Australian home built to current minimum standards could see up to 15 air changes per hour. Now, just for the record, that information is old. So if that is incorrect, I do apologise. But in older homes, you can actually see that, see a higher air exchange per hour. Our air changes per hour is measured using a blower door test. And this is done by a third party. And it's at lockup before plaster, but after services have been run, and then also on completion. Now, the reason we do it after the service has been run, because there might be some penetrations through the internal air barrier, which you can see in the picture there, the Intello. And we'll also show us a video later about how we install that. Next slide. Oh, so typical wall build-ups to achieve airtightness. So we're generally relying on our internal air barrier as our primary air barrier, but we do try and manage airflow or the tightness of a building externally as well. Now, in a practical sense, we do this using a high quality external weather resistant permeable barrier like ProClimber Extasana. And this is like wrapping the building in a Gore-Tex jacket. It protects the building from moisture, so it doesn't allow moisture to get in, but allows moisture to move out of the building. And the building doesn't sweat, so it doesn't, have an opportunity to build up moisture within the wall cavity, which could lead to the degradation of the frame, but also mould, so an unhealthy building. So it's our first barrier of air movement. So it stops the movement of air through the insulation. So this is really important as it allows the insulation within the wall to perform as it's designed. Now we'll tape all our joins, our pipe and cable penetrations, and we'll also tape in our windows and external doors. Now internally, we'll use a barrier like ProClimber Intello. Now just for the record, I'm not sponsored by ProClimber. It just happened to make some really great products. Similar to the external wrap, the Intello allows the movement of moisture from inside the building to outside, but that's not air permeable. This is our primary airtight barrier. And similar to our external wall building, our membrane, we'll tape all the joins, pipe, cable penetrations and windows and external doors. So we'll do that both. So you've got a couple of levels of redundancy there to help with airflow. But why would we build an airtight building? It allows us to have the full control of the internal building environment. It ensures that continuous insulation is performing as it should. It eliminates any heat loss through gaps in the building envelope. It also helps eliminate the build-up of mould inside the wall from cool air movement from outside and to in and vice versa. Far less heating and cooling loads. And it also ensures that the HRV or ERV works more efficiently. And to talk a little bit more about the HRV and ERV, I'll throw it over to Jess.
Thanks, Hamish. Alrighty. So the heat recovery ventilation system, or mechanical ventilation heat recovery system, is commonly what they're known as. These two items are very similar. Actually, they're pretty much the same thing, apart from an extra word thrown in there. So there's another one, the ERV, energy recovery ventilation. Now this unit is slightly different. So this unit actually transfers moisture as well as heat. So typically you're not going to see one of these units down here in Melbourne. They're going to be up much north, sort of up Queensland, I would say, where the humidity is quite high. You know, in the passive house world, you always say, you hear that the HRV is the heart of the house. It's pretty true, I guess. It circulates filtered fresh air throughout the house, which is essential, as Hamish was saying, with having an airtight barrier. Now, there's two types of HRVs. You've got the centralised unit, which is the unit in the picture here, and you've got a decentralised unit. Centralised one is you would have inside the building and ventilates a full house. A decentralised one is something that you would have, which you would install in an external wall, and that would just ventilate a single room. Haven't had to use one of them myself, so I guess I know a bit more about the centralised unit and how they work. So if you have a look at this image, you'll see the unit exhausts moisture and odours from the bathroom, kitchen, sort of utility rooms, puts it into the exchange, the heat exchange, and actually exhausts out the stale air. On this side, you can see we've got fresh air coming in. The fresh air will get filtered. Also, the heat from those utility rooms is absorbed through there, and then they come into the habitable rooms, bringing warmth gained from the exchange. So we've got a few slides here. We'd like to sort of explain a bit more about units and how they're installed. This first unit here we'll talk about first. So this is the smallest centralised unit you can get. We installed this one in 2019 for Premier Homes. We've got a display home we partnered with, and what we've done is we've actually left this utility room unplastered, which is great for when people are walking through. You can actually see the guts of how it all works. Also with the ducting, I guess we took it as a first in, best dressed basis. So we got these pipes in before the plumbers and the electricians got their stuff in. I think it's much easier for those guys to do their wires and pipes around our bigger pipes. Next unit is a centralised unit as well. This is a much bigger unit. This unit's designed for say like a 4-bedroom home. We've got 2 boxes on the top right hand side here are attenuators. Now these are actually silencers, so it's very important that these are installed, and these actually aren't mandatory, but we make sure we do put them on all our jobs, because the last thing you want is a noisy system. These actually work really well. And this unit itself is a very efficient unit. It can recover up to 90% of the energy taken from the building. So generally in a passive house building, the heat is generated from body heat, cooking, lights. Those sort of heats is enough for the HRV to pick up the heat and then obviously filter it through the rest of the house, like I explained before. Alrighty, this is probably our latest project, which we created a 150mm service cavity space for the ceiling. It actually worked out pretty well. We run the ducting in first, like I mentioned before, so easy. Then we had our plasterer come in. He installed his suspended ceiling. It worked out perfectly with the 90mm ducting to fit in between the 35mm batten and the fairing channel. And also plenty of room for the electrician to put his downlights in too. So it was just a nice, easy solution there for that. And our final image is from a completed house of ours. We had the unit tucked away in a laundry cupboard. It's a pretty neat solution, having it tucked away in the cupboard here. Another benefit of having it in the laundry is you're close to a sink, so you can actually connect the condensate drain into the waste pipe here. So it's just another thing to note, that if you are going to put one in its own utility room, I would suggest you remember to put in a waste pipe penetration at the time. There's a few other things we think is worth mentioning about HRV installation. If you're going to install a HRV in a passive house, it's pretty essential to try and get the unit inside the thermal envelope. Two reasons: if you do run your ducting outside the thermal envelope, they're going to have to be heavily insulated, because you don't want to lose that conditioned air temperature inside those pipes. And another reason, you're actually going to be penetrating the airtight membrane, so there's potential for leaks there. So if you're going to put one in a passive house, always try and keep it inside the thermal envelope. They also come with bypass modes. So generally bypass modes you will use at night time. So if you've got a few warm days and the house is slightly overheated, what you do at night time when it's cooler temperature outside, flick the unit to bypass mode, and it would, instead of exchanging inside the unit itself, it would bring fresh air straight from the outside, filtered straight into your house, so enabling it to cool down. It also comes with boost switches as well. Actually, I'll go back to that bypass mode. I guess, like Hamish said, you've got the Passive House windows, which is, they're a beautiful product. Don't forget, they're always operable. So if you're going to need some night ventilation, open up your windows, get some cross ventilation. It's going to be the best method for some night cooling. So back to the boost switch. So you can get boost switches, and you'll put them in your bathrooms or your laundry, your kitchen, and what that'll do is that will speed up and help extract the moist odours and the moisture and the odours much quicker. One last thing, it's pretty common in passive houses to have a recirculating range hood. Now, just note, these cannot be directly connected to a HRV. You have to make sure that the range hood charcoal filters do their job first. And all right, well, we're going to shoot over to Hamish's video. So I'm just going to unshare my screen. You can see that, no worries.
Yeah, I can see it, Jess.
Okay, so we just briefly wanted to touch on comfort. So typically passive house optimal indoor air temperature will range from like a 20 to sort of 25 degrees all year round. That's what we're aiming for. We always get the question, so a passive house doesn't need a heater or air conditioner, doesn't need heating and cooling. And well, I guess that's a pretty hard question to answer, because everybody's different. So generally a passive house can overheat up to 10% of the year. In the PHPP calculations, it does allow it to overheat. So there might be a heat wave in summer where the house does get over 25 degrees for a few days in a row. So it depends on the person. If the person's can handle the 26, 27 degrees, whatever it might be, for a couple of days, well, then that'll be fine. But some people absolutely not. So we always recommend to put an air conditioning unit, a split system, in our houses regardless, because at the time of construction, when you've got taping and membranes and all that sort of stuff happening, you can actually install the unit properly. Whereas if you try and retrofit one later, you're obviously going to have difficulty with that. So I guess the answer is depends on the individual, but I would put one in myself. Just touch base on certification as well. Obviously, some people say, is certification required? Well, I guess that depends on the individual, the build, the design, the budget as well. I guess the way I see it, you've got a third party overseeing the job. There's not too much in it, as if to say, like, you're going to take these extra steps to reach these goals anyway. So you've got things like blower door tests you have to achieve. You've got commissioning from a HRV. You've got to provide a construction report to the certifier from our construction manager. I think it's totally up to the individual, and it's not something that I preach. It's definitely something that's up to the person. How you going there, Hamish? Are you getting close?
Let's have another crack. I do apologise, guys. I'm a builder, not a IT consultant, so we'll see if I can share my screen again, Jess. And once if you can have our Mento ProClimber wrapping, that then leads into or flows into our Solitex Extastani here, and that's all taped through here. And we wrap the whole building with this particular product. The other thing you notice here is we have our offset patterns here on the roof and on the walls. What that does is allows any moisture that gets into the wall and roof assembly to drip down here, get into the wall cavity and actually get out the bottom. Typically this will be ventilated, so it'll have airflow through it. So this wall assembly will remain nice and dry throughout the life of the building. The other thing you can see here is we've got our UPVC window, and Ryan's taped this up to the membrane. So this is a complete watertight unit as is. So we could have the frame up, wrap our buildings in our external wall membrane, and we're basically watertight, we're ready to go. So we can have guys working inside and outside. One of the other things I'll talk about here as well is that this is not considered our airtight barrier when we're talking about airtightness in Passive House. It all does work together, and this is essentially airtight as it is, but its function is to allow the insulation within the wall cavity to work how it's meant to. So think about going outside and putting a jumper on in winter. You'll remain warm for a little bit, but if it starts to rain, that jumper is going to get wet, and that jumper is not going to provide any warmth. What we're doing here is essentially putting a Gore-Tex jacket over the top of that jumper. So the wrap is going on top of the insulation. And that's that Gore-Tex jacket that I'm talking about allows the insulation to perform how it's meant to. This does stop airflow from going through the insulation, so it allows the insulation to trap the warm air inside. So inside this wall assembly here, we've got 140 studs. So we've got an R4 insulation back within the stud. And we know that by wrapping our buildings with this membrane, those R4s are working All right, so what I want to show you now is essentially a cross-section of the roof, the wall and the floor. I guess just to demonstrate that we require in Passive House to have continuous insulation. So we actually have the insulation here at the moment. You can see that we've got continuous insulation through here, down the wall, and along the floor with no thermal break. So there's, aside from our timber structures here, so our timber members here, we have continuous insulation the whole way around. Now this is a really crucial element in Passive House.
and a really crucial element to get right. But myself, just to talk more about the internal side of the Passive House layering and this Intello wrap, which primary factor is to really create an airtight barrier, because with all passive houses we've got to get down to a 0.6 air exchange per hour, which is measured using a blower door test, which I'm sure the guys will speak to you a little bit more about, and how we get there, and what's what the effectives on a passive house that will be. So from this Intel, as you can see, still using the tapings to make all the connections and make that airtight. One thing you'll see on the internal side that you would have seen on the outside is these smaller pieces cut up. So that's actually covering up our staples that are the initial hold for the Intel onto the frame. As well as on the internal side, that doesn't take place side is this wrap for the window to connect to the inside of the Intello. So as you'll see in a quick time lapse here on how we actually fix that Intello to the window and then onto the Intello on the internal side. Finally, you'll probably see on the floor down here, we've just got a chipboard floor, which is obviously a pretty common material in the building industry, but that's actually also considered an airtight layer, as it's connected with the tape to the Intello on the internal side. So I touched upon the window, but the actual performance of the window is probably just as critical as all the taping and all the paper that goes into it. So this we've got here is a triple glazed high performance UPVC window. UPVC is a material that's a very low conductor of thermal energy. So as opposed to like an aluminium window where the heat and cold transfer through really quickly, this will act almost like an insulation on its own. Important to note that it still does act like a window if you wanted a breeze coming through or overnight, just with that security function. So it does have two opening functions, but while in the lock function there, it is completely airtight as part of that external layer, because that is the aim of our existence, is getting these windows in and airtight. Similar to doors are right up there with getting that right. So having a product like this that actually helps us get it airtight makes it life a lot easier.
Well, I'll chuck back over to you, Jess, and sorry everyone about that technical difficulty there. We got there in the end.
No worries, mate. Good work. All right, so okay, yeah. Last thing we want to touch on before questions is just the categories which we have for Passive House. Passive House Classic, your typical Passive House. I mean, they're all fantastic. You've got Passive House Plus. Now that just produces as much energy as what the homeowner consumes. You've got the Passive House Premium, and now that's producing way more energy than what the household consumes. I just wanted to also touch at the sustainability credentials of Passive House is more on the low energy consumption it uses. It's not so much about the products and the embodied energy in the products. So I think it's pretty much time for questions, Hame, if you're ready to roll, mate.
Hopefully we can fumble our way through any answers that we don't know.
All right, Simon.
All right, you guys ready to go? We've got plenty of questions here, as you can imagine. I'll start from the top. So I'll throw this to either of you. How does a HRV work in a warm season?
Oh, I guess I can touch on it since I've been talking about the HRV. That's a good question. Yeah, in summer, the HRV, instead of retaining the heat in the heat exchange and putting it back into the building, it will put the heat outside, and it will use the cooler air into the building. So it's not actually, you're not actually going to be pumping heat into the house, and obviously the moisture in the air too, it will take care of that. like I said before, if the humidity is too high, that's when you're going to start to require an ERV, not a HRV.
Got you. And another one, Jess, in relation to HRV from Daniel Worm. Can anyone do it? Can anyone install a HRV, or do you need to use a HVAC expert?
Yeah, look, I generally say if you're a certified passive house tradesman, no doubt I could say you're capable of doing some duct work. But our first job, we got a professional contractor in to do the whole unit, and now we get them just to commission it. I wouldn't, if someone that's never done it before, I wouldn't recommend attempting it themselves. Yeah.
All right, Haim, I'll throw one to you. How does the external wrap work around the roof truss where eaves exist?
A good question. So you can do a couple of things. You can actually continue. So you've got two membranes that we use externally. We've got like the black wrap, which is on the top, and that's our Mento. That's got a higher UV resistance to it. And then our blue wrap on the walls. What we'd normally do, well, there's two ways we approach it. So we either wrap it all the way around and underneath, and then the roof wrap will lap over the wall wrap and we'll tape that. Alternatively, if you've got trusses spaced at 600 or 900 centimeters, you can just cut the wrap at the wall and then just fold it over, and then you just need to make sure that you tape around all your rafter tails or truss tails. So there's a couple of ways of doing it. Probably the easiest way is just to wrap it over the top. In our experience, we kind of like to cut it. Find it just a little bit easier to wrap. It's a little bit more taping, but I think we can, a known cut, as Ryan said to me the other day, a known cut is easier to tape than a fold or a roll in the external membrane. But look, everyone's got their ways of doing it, and it's probably sometimes case by case, whatever's easier. But they're the two ways that we've done it.
Got you. Okay, there was another great question here, and now I've lost it. I'll throw to one here. Aaron Powers asked, how can I become a certified passive house builder?
Well, you can jump on the Australian Passive House Association website. They'll have some data on there about who's currently doing courses. I know there's down here in Melbourne, there's Smart Building, it's by Daniel Cresson, and Box Hill Institute. But I'm sure if he jumps on the Australian Passive House Association website, it will tell you all around Australia where you can do that course.
I know that I guess during these times of COVID as well, that a lot of these courses are going online now too. So Smart Plus Academy, I think Daniel's based in Sydney, but I know one of my guys have done his online course, and I know when we did it, it was at Box Hill in Lilydale. Box Hill TAFE in Lilydale by Burkhard. So both are really, really good. But jump online for sure.
Perfect. Another interesting one here from Ty McQueen. In the case of an extension, is retrofitting the existing part of the building feasible, and what's involved in retrofitting?
Jess and I talked about this one actually. So I guess you need to think about that any building element that you increase the performance of is going to increase the performance of a house. So if you just wrap a bedroom, that's obviously going to perform better than a bedroom that's not wrapped. So I think it's important that every opportunity that you get when you're doing renovations and extensions, we do a lot of them, that you are doing whatever's the most reasonably practicable to increase the thermal envelope of the building. Sometimes it is really tricky when you're talking about insulating floors. Jesse's probably given a really great example of how you would insulate a floor, I guess without having to go underneath, and that's putting PIR board over the top of the existing flooring. there is actually a class of passive house called an NFIT certification. It's not something that we touched on today because this is just an introduction. But look, my advice is that the more passive house principles you can include in a home, even if it's just updating the windows, the better the house is going to perform. So don't think that because you can't do everything that that it's useless or it's not something you should do. I'd be trying to implement as many passive house or high performing building elements as you can in any project.
Yep, great. I found this question from before, it got upvoted, so people want to know. How are holes for items like power points and light switches managed where there is an opening into the wall cavity?
Oh, Jess.
All right, so what we try and create is a service cavity in the inside area of the wall. So generally, you don't really want to be penetrating the airtight membrane with anything like light switches, lights. You are going to have to penetrate these to get pipes, cables and stuff into the building, but you try and have that in a concentrated area and then you'll spread it out. So we'll have, depends on the builder. We do 35 mil for our battens, and some spots in bathrooms we might have to have 45 mil for a mixer to fit in. Although we do try and keep any mixers and switches stuff off the external walls if we can. Try and keep them in the internal walls, because the internal walls is just like just a conventional stud wall. You can just go straight through like you normally would. Penetrations like cables and stuff, sure they can go through. You just got to make sure you put some airtight tape, or you can actually get some grommets, all different size grommets depending on the pipe and the cable. So yeah, you can get light switch boxes that go into the airtight membranes. I haven't had to use them myself though. So.
All right, good to know. We'll go with a couple more questions. Haim, I might throw this one to you regarding that window. So after the Intello wrap is fixed around the window and the window is installed and taped, how is the window fixed to the frame? It's a very chippy question.
Yeah, so it is hard to explain without showing, but on that particular window, so that's a UPVC window, there's actually some metal brackets that's attached to the side of the window. So they'll go on the outside of the wrap. So our Intello will get taped around the window, and then behind that is the clips. So on the same plane, but behind it on the clips. Before we pull our airtight membrane over the internal airtight membrane, we'll actually just screw those into the wall. But look, there are a number of ways. A lot of other windows have like a cover plate that comes off, and you can screw through that. But in that particular example, there was 4 clips on there that we screwed in, and then it's all taped and externally and internally. That window's not going anywhere, and we would then typically foam fill around, as I said. In the video, we didn't actually get around to foam filling it, but yeah, that's how we do those UPVC ones.
Beautiful. All right, we'll go with Alistair Han has asked about heating and cooling. When in Melbourne and it's 40 degrees for a few days, are you saying that most likely the house will stay between 25, 27 degrees without much AC? That's the question. And what about winter? Let us know how the home will operate in winter.
Well, I guess if it's been designed to passive house criteria, it's going to have specific shading on the windows. So in summer, they're designed to stop it from overheating. Now, it's kind of hard to say if you get a number of days of 40 degrees in a row, you potentially are going to have some overheating. So therefore, I would say, yeah, some air conditioning throughout the day, but very minimal will be required to bring that temperature back down again. As for winter, generally, I would say passive house would stay between that 20 and 25 degrees all year round. because the PHPP will calculate the people living in the house and the heat gained from the appliances and stuff should be adequate enough to keep that house to that temperature range. So generally your splits are only used for cooling here in Melbourne.
Very comfortable home, yeah. All right, we'll go 2 more questions. They're both on. Everyone's very curious of how these HVRs work. So on the aircon side of things, yeah, how long does it take for the HVR to evenly distribute warm or cold air around the house from a single AC unit?
So it's probably important to know, or important to point out here, that these HRV units are running 24/7, 365 days a year. They're constantly circulating air around the house. How long does it take for it to, I mean, I couldn't tell you. I mean, a minimal amount of air cooling will cool the home reasonably quickly. How long, someone else might be able to answer that. But the units are quite efficient. If the house has been designed correctly, I mean, you're only talking, is it 10% a year, Jess, that you 10
yeah, it's about 30 to 35 days of the year that you've got potential overheating issues.
Yeah. So
yeah,
it's not running all the time. How long? I don't know. Jess, can you answer that? How long it would take to cool the house back down again?
Yeah, look, I think it's around in the 15 to 30 minute range, generally because the temperature's not really going to get that much higher than 25. You know, you're not going to be getting 35 degree temperatures. It's going to take you an hour or 2 hours to bring the temperature down. So it does happen pretty quickly.
Yeah.
Okay, last question. So, Jess, throw to you. Would you combine a HRV and an ERV with a dehumidifier?
That's a good question. To tell you the truth, I don't know too much about the dehumidifiers. I know that the purpose of the HRV is to transfer moist humidity and heat. So that's probably something that we'd probably have to maybe speak to one of our contractors about that one. Yeah, not too familiar with that.
If anyone knows the answer to that, get in touch with me, because we've got a internal pool which we're trying to work out at the moment, and everyone's scratching their head. So if anyone has the answer to that, send me an email. I'd love to know.
Bring it over.
Bring it over.
All right. Well, thank you to Hamish and Jesse. Huge, incredibly informative and educational on Passive House. Again, Builders Declare, connect with us through our website, au.buildersdeclare.com. Get in touch with us on Facebook. We've got a Facebook group, Facebook page, Instagram, and we'll see you back here again. I think it's about Wednesday, the 20th of October?
15th, I think, is this one.
Sorry, it's the 20th. Yeah, it'll be the 14th or the 21st. We're undecided on the date, I think. But, yeah, look out for the email. This webinar will be available. We'll send it out to each of you, and it will be available on YouTube. And for those that want to incorporate this webinar with CPD points, you can do that at the Green Building Institute, which we'll send some more information about. And again, thanks again, guys, for joining us. Great response from Australia, and we'll see you next month. Thanks again to Jesse and Hamish.
Thanks, everyone.
Thanks, guys.
Cheers, guys.
Cheers.
Thanks,